Hello teacher, my name is İsmail. Now I will explain how this program works. We have three different classes in here, maybe four, there is one more class. This class holds a reference to the root node. It contains methods for creating a tree, retrieving the root, and obtaining an iterator for level order traversal. Other one is node classes in here. A static inner class that represents a node in the binary tree, and each node stores data and has references to its left and right children. And there is level order iterator class, an inner class that implements the iterator interface. It traverses the tree in level order using a queue, and that's it. There's a tree demo. This is which class we try the method and create an object. Now I will add a breakpoint and explain the codes with debug like this. Okay, let's start. In here, a new instance of binary tree is created with 1 as the root value in here. A new node with the value 1 is created, and this node becomes the root of the tree. When I press the F5 button, it's go enter the binary tree class, goes there, and calls the constructor of this class and creates a node in here, and return to when we create a node, we will go to node class, and we explain and define the elements in here, and left and right equal to null right now, and we back to tree demo again. Other line, there is a binary in here. The get root method's called in here to fetch the root node. It simply returns a reference to the root node 1. We enter the binary tree and calls the get root method in here. After that, returns the reference to the node and back to tree demo again. Other line, two new node objects created in these two line. 2 is assigned as the left child of the root node 1. This is the left, and 3 is assigned as the right child of the root node 1 in here. It seems like in the top of 4 and left side is 2, right side is 3. When we go to binary tree class, we define these things, and right we node constructor called right now and creates 3 node with the value of 3, and when we define it, we back to tree demo again. After this 4 line, additional nodes are created and assigned. 4 and 5 in here as the children of node 2. 6 and 7 as the children of node 3. First of all, when we press the F5 button, we enter the node constructor again and creates the node with value 4 in here, and enter the node constructor again and creates the node with value 5, and again it's for 6 here, and it's for 7 in here. Now This is a print statement to indicate the beginning of the traversal, and this line explained. And in the console, this part must write like this: a level order traversal of the tree, like this in the console. After that, the get level order iterator method is called in here. Any level order iterator instance is created in here. Inside its constructor, when we go there, I'm sorry, in here, a queue is initialized. The root node 1 is added to the queue in here. Now our return new, and this line is finished. Queue state is 1 in here. In this line, there is a loop. A while loop starts continuing as long as there are elements in the queue, because of the hasNext method. And hasNext method checks if the queue is empty, and the next method is in here. The next method is removes a node from the queue, adds is left and right children if present to the queue, prints the value of the node in this method, next method. Now our queue start states during each iteration. Our first iteration is hasNext equal to true, and when we go to hasNext method, it is true. Next method, we call next method in here, it removes 1 from the queue, prints 1 and adds 2 and 3 to the queue. Now our queue state is 2, 3. In here, removes 1 from the queue, prints 1 and adds 2 and 3 to the queue. Now go back again, and second iteration is hasNext is true, and this is true, so iterator.next, we call the next method again, removes 2 from the queue and prints 2 and adds 4 and 5 to the queue. After these lines, our queue state is 3, 4, 5, and third iteration is hasNext is true again, and in here we call the next method again, and in here removes 3 from the queue and prints 3 and adds 6 and 7 to the queue. Now after these lines, our queue state is 4, 5, 6, 7. In the fourth iteration, hasNext is true again, and next method is called. After this line, we remove 4 from the queue and prints 4. Our queue state is 5, 6, 7 after this line, like this. After that, fifth iteration is here, and hasNext method is true, and next method called after this removes 5 from the queue and prints 5. After that, queue state is 6 and 7, and 5 is printed in here. After that, hasNext method is true again, and removes 6 from the queue with next method. in here. After that, 6 is printed in here. And 7th iteration is has next is true again. In this line is true, and we call next again. Remove 7 from the queue and print 7 after this line. After that 6th iteration, we checked when we go the has next method, there is a false, so we skip this line and finish the program. Now I will explain time complexity with pen. First of all, I want to talk about the constructors. There is a binary tree constructor in here. It is O1 because this constructor implies the root node of the tree. It creates a single node with the provided data. Since this only involves one operation and creating a node, assigning it to the root, it takes constant time, so it's equal to O1. Other one is node constructor. This part, it's O1 too. The node constructor simply assigns values of the data left and right fields of the node. So since this is a fixed number of operations and doesn't depend on the size of the input, so it takes constant time and so on. After that, we talked about get root methods in here. Its time complexity is on 1 2 because the get root method simply returns a reference to the root node of the tree. Retrieving a reference is a constant time operation as it does not involve iterating over or processing any data, so it's equal to O1. And get level order iterator in here, we talked about this method. This method is O1 2 because this method creates and returns returns a new level order iterator instance. The instantation of the iterator doesn't depend on the size of the tree and involves only a few operations, so it takes constant time. After that, level order iterator constructor in here. Level order iterator. This is in this constructor a linked list is created, so and the root node is added to the queue if it's not null. The operations involved are constant time, initializing a queue and adding one node, therefore constructor runs constant time, so it's equal to O1 in here. O1 has next method in here. It's O1 because simply O1. This method checks if the queue is empty. The operation of checking whether a queue is empty is a constant time operation, so this method runs in O1 time. There's a next method in here. This is a little bit complex. O1 per call, but ON for full traversal. Why? Because polling from the queue is an O1 operation. This part. And adding left and right children, not queue offer this part, left and right, is also O1 for each operation. During a full traversal of the tree, this method is called for every node, and since it performs constant amount of work for each node, The overall time complexity for the entire traversal is On, where n is the number of nodes in the tree. It's O1 per call and On for full traversal. Thanks for listening. Our program is finished and time complexity is finished. See you next week.